Welcome to another thrilling episode of the Mindplex podcast. Today, we have two of the founders of the Artificial Superintelligence Alliance, Trent McConaghy and Ben Goertzel. Ben is usually our co-host, but today he is our special guest along with Trent. And of course we also have our producer and co-host, Lisa Rain. Say hi, Lisa.
Hi, Lisa.
Let's start off by introducing our guests. Ben and Trent are both co-founders of the Artificial Superintelligence Alliance, along with Humayun Sheikh, CEO of Fetch.ai. If I may, I would like to start off saying a few words about Trent and his background. Thank you.
Please
Let's
do.
hear it.
Does she want to say words?
Everyone please say hello to Trent McConaghy, a self-described solar-powered visionary who co-founded Ocean Protocol, a groundbreaking platform at the cutting edge of decentralized AI. Trent is helping to unbind AI technologies via blockchain, enabling decentralized prediction feeds that promise to boost AI's capabilities exponentially, backed by solid, real-world physics. His ultimate mission is to ensure that humanity retains a meaningful place in an increasingly automated future, and is also an advocate for brain-computer AI interfaces and believes that BCI/AC is the path. Welcome, Trent.
Thank you very much. Great to be here.
You're not going to introduce me, Desdemona?
Next, we have our own drive. Ben Goertzel, who needs no introduction as you probably already know him as a host on this very podcast. Ben's also the visionary CEO behind SingularityNet and has been actively researching and developing AGI systems for more than 30 years. Welcome, Ben.
Thanks, Desi.
Today's podcast has been a fascinating journey.
No.
Ben,
We're
could
done
you start
already?
by giving us a brief overview of the Artificial Superintelligence Alliance and its objectives, what you mean by beneficial AGI and why it's central to the ASI Alliance's mission?
We can do that, Desi. I've been thinking a bit about how we should best use this podcast time, though, and I'm actually interested to dig in with Trent into the different but overlapping approaches we have to building AGI, because we've done some other podcasts recently just on the ASI Alliance and what it is, and we both tend to get bored repeating the same stuff over and over. So I will though answer your question briefly. So I'm in the ASI Alliance. It's a tokenomic merger of three relatively long existing decentralized AI projects: SingularityNet, Ocean Protocol, and Fetch.ai. SNet was founded in 2017. Fetch and Ocean around the same time, I think, doing public token stuff in 2018. We're all sort of building decentralized AI agent systems in different ways with different foci, but aimed at allowing the world's AI to be run on a bunch of different machines owned and controlled by different people cooperating in different ways. The ASI Alliance was formed by sort of merging the utility tokens associated between the two projects into a single utility token, the ASI token, now trading under the ticker symbol FET from Fetch, but they'll be changed before long to the ASI ticker, and as well as merging our utility tokens together, sort of for simplicity of users and token purchasers. We're now engaged with some collaboration aimed at seeing how can we put our different technologies together to make some products that back end in all three of our decentralized networks, alongside the individual product development initiatives of each of the platforms. We're shortly merging in Kudos, which is a decentralized AI compute provider, into the ASI Alliance as well, and we may grow the alliance further by doing tokenomic mergers of other entities. But what has inspired both Trent and myself to get into this whole business is trying to make smarter and smarter AI systems, doing more and more interesting things and running on decentralized networks. And being a decentralized thing by nature, the ASI Alliance is, it's broad enough to foster a few different approaches to actually causing AGI to emerge. And I think it will be interesting to dig into the different approaches to getting AGI to pop out of these decentralized networks.
I don't have much to add to what you said, Ben. I think you did a pretty fair summary of what ASI Alliance is about.
So, Desi,
Great.
since you're being okay,
Let's move on to the recent expansion by merging Kudos into the ASI Alliance. What unique capabilities does this bring to the ASI Alliance?
I mean, Kudos has a bunch of server farms, and they have a substantially decentralized platform, which allows people who need AI server compute for their AI jobs to go on their platform and find compute from various different providers. And there's a few centralized bits in Kudos's infrastructure, which we're working with them to make more and more fully decentralized and blockchain based. But I mean, pretty much they're providing compute hardware and a decentralized interface to that, whereas Ocean, Estet, and Fetch are more sort of like a middleware that would run on top of this hardware. And then my work on OpenCL Hyperon, an AGI platform, and Trent's work on Predictor, a sort of crowdsourced prediction framework viewed as part of a thrust toward AGI. These live on a yet higher level on top of the middleware layer that lives on top of the hardware.
Trent, could you elaborate on the concept of BCI/AC in the context of superintelligence?
I'm happy to. Do you want to jump into that, Ben, right now, or do you want to? I think you wanted to cover this other stuff first, right?
I think, Desi, that we want to get there, but I think I agree with Trent's intuition. I think Trent, it would be good if you could outline what Predictor is, and then how you see Predictor or generalizations of Predictor potentially playing a key role in the emergence of AGI.
Yeah, sounds good. So, given this is a podcast, and there was a brief bio of me at the beginning, another very brief bio of me is I grew up in a pig farm and then became an AI researcher. And that's actually not far off. There's a few steps in between. And on that, farm growing up, we had pigs. We also had a lot of grain. And every morning when it was seeding time or harvest time, every day, in fact, every hour on the hour, 7 o'clock, 8 o'clock, 9 o'clock, my father would shush us and we would all have to be very quiet and listen to the radio very intently for the weather report. Why? Because if it was going to rain, then we better hurry and get the tractors off the field, because otherwise they'd be stuck in the mud and we lose days from the tractors covered in mud and wrecking out the crops that we just planted or otherwise. And vice versa too. If it was raining, we wanted to know how quickly is it going to clear so that we can get out there and do seeding and harvest. And with seeding and harvest, every day counts, because if you don't get your seed planted in time, you only have a limited growing season, and in the end of the fall, the snow comes. So if you plant your seed too late, or if you take off your crop too late with harvest, then you are snowed in and you lose the crop. So every hour counts. So and then from that, therefore, tracking the weather and understanding what's happening. Is it raining or not? Is it going to freeze or not? Etc. This really matters. And so we came to live and breathe, and live and die in terms of profitability, making money as a farm, by the predictions of the weatherman. The thing is, he was wrong a lot of the time, right? Or she. But it was no skin off their back. They didn't make any more money or any less money if they were wrong. If they said it was going to rain and it didn't, and it hurt us as farmers, wouldn't affect them at all, right? Which is kind of crazy, right? You would think that there would be some sort of incentive for more accuracy, but there wasn't, right? But what if there could be? What if there could be a better way to be more accurate, where if I'm more accurate in predicting weather, then I can make more money. Or if I'm inaccurate, then I lose money, right? And not only that, what if instead of just relying on some centralized weather reporting service, typically funded by the government, what if you could have a bunch of people, 10, 100, 1,000, 10,000 people, all contributing their own expertise by doing their own studies on the weather, running their own AI and machine learning models, all of that, and sort of collate it all together. And the people who are the best tend to rise to the top because they tend to make more money. And the people who are less good at it tend to fade away because they're losing money, right? That's basically the heart of what we've created with Ocean Predictor. We started with predictions not for weather, because it's hard to make money there at the beginning. Instead, we've focused on trading of crypto tokens, because the obvious customer for that is traders. And so there's traders that come along and they buy these aggregated prediction feeds. Will the price of Bitcoin go up or down, yes or no, 5 minutes from now? And it's, say, the Bitcoin USDT pair on Binance. And so it's, you know, for Bitcoin, for Ethereum, for the top 10 tokens by market cap in general. And so this is what we built, and all of this is on chain. So people submit their predictions on chain, they get the results on chain, they get paid out on chain, it's all on chain. And of course, when people submit predictions, if it's every 5 minutes for 10 different feeds, that's going to get tedious very quickly, right? You can't really handle it, especially if you want to have AI, ML in between. So of course you're running bots. You're running scripts that run these machine, bots. These bots themselves are taking in previous historical prices of data, previous historical prices, and any other data they want to. It could be Twitter sentiment data. It can be weather data, whatever they want. And they use that to predict, will Bitcoin go up or down? Yes or no, 5 minutes from now. So that's the heart of what Predictor is about. And there's the traders, and then there's the people submitting the predictions. We call those predictors with 2 O's as a nod to how DeFi land works. And at the end, it's gone really well. So we launched it about a year ago as an application on top of Ocean. It was actually the first time we truly tried to build an application on top of Ocean. And the volume is growing steadily, exponentially, in fact. And these days we're doing about $100 million volume a month for the prediction trading for Predictor. And we still see it as early days. So while we started with crypto predictions, we do plan to expand to weather, to energy price prediction, energy demand prediction, marketing, logistics, and a lot of other applications. And it might sound pretty mundane, but yet at the heart of it, think about what ChatGPT is, right? All it's doing at the heart of it is it's taking your query, 10 words or 50 words or a paragraph, and then using that as an input to predict the next word or the next, and then maybe it has to have a whole sentence. So it predicts the next word after that, the next word after that, the next word after that. So it's basically prediction. And at the heart, prediction is the essence of intelligence. Some people say prediction, all there is prediction, right? But for sure, it's the essence. And around that, maybe you need some agentism and so on. And I would advocate that too. But prediction is certainly a key component for intelligence. And with Ocean Predictor, what we've been doing is saying, let's crowdsource this. Let's put this into a very special incentive game on chain, where it's a very simple game at the heart, right? If you submit a yes or no, if you submit yes and stake against it, if you're right, you make money. If you're wrong, you get slashed, you lose money. And the multiple stakers together, all that signal gets aggregated, and that's the feed that gets bought by the traders to decide, to get extra alpha when they're trading to buy Bitcoin and otherwise. So that's what it's about. But we're very hopeful for the long-term future for this too, for the day-to-day mundane prediction tasks. But imagine if you're really trying to predict weather, say every square kilometer on the planet. There's 500 million square kilometers on the planet about. So that means if you're going to have, say, 7 feeds for each square kilometer, temperature, precipitation, humidity, air pressure, a few more, then you're looking at 3.5 billion feeds. Obviously, you wouldn't train each one of those as, you wouldn't have 3.5 separate billion separate models. You'd probably want to train one big model, and it would implicitly infer a dynamical system model, one huge model for the planet Earth, right? At the level of the large scale weather mechanics, et cetera. But in order to get good at it, it would basically be a highly intelligent model. It wouldn't be trying to, answer questions like ChatGPT might. It's really trying to do something else, right? But nonetheless, it's super intelligent because it's just covering so much ground in its own way, right? So intelligence takes all different sorts of shapes and sizes. The intelligence that we know as humans is, because we know it, we live it, we experience it all the time. That's the most, commonly understood intelligence. But a cricket has intelligence. A whale has a much larger brain than we humans, but a lot of that is dedicated to GPU resources for, finding their way in the sea. Same things with dolphins, right? They've got giant GPUs inside them, and bats as well. So anyway, there's all these different sorts of shapes and sizes of intelligence.
You're thinking of a GPS, maybe?
No, a GPU, literally. Dolphins, they do when they do echolocation, and bats, right? So they actually send out these signals, sonar signals, and then those bounce back. And
right. So that's like a geographical positioning system, not a GPU, which is a processing unit.
No, but it's actually used as a GPU as a processing unit in order to infer the structures. So it's not trying to find an XY coordinate on the planet. It's actually trying to identify the structure of the geography around it, right? For sort of inverse 3D modeling, basically. Yeah. Right. So it is GPU type modeling as well. And actually, if you look at their visual cortex, they have massive visual cortexes to do this processing, right? Yeah.
No, so that's even. It seems in dolphin or whale communication, they may be like sending across continuous wave information in their language rather than chunking it into discrete things. Like if we could send a continuous map to someone else in a chunk, right? Which, they're quite interesting.
For sure, I'm sure they're doing a bunch more stuff too. Yeah, and whales too. Like they definitely have languages, and their brains are harder to understand, I think, than dolphin brains, because dolphin brains have the straight up GPU stuff, whereas whales, we don't really understand whale language that well. Although, as a hilarious aside, people are using LLMs these days to apply to translation of animals, right? So we're starting to actually get, sort of translations of animals and trees and more.
And the mycological
like
networks
about complex
mushrooms.
Information.
Yeah.
Could you repeat that?
What was that, Desdemona?
She said it seems like you're processing a lot of complex information.
A lot of complex information. Let's shift gears for a moment. Considering all these innovative technologies and predictions, how do you think they will impact the everyday lives of most people? Do you see a future where technology becomes seamlessly integrated into our daily routines, or is there a learning curve we must first overcome?
I can answer this. I mean, technology is obviously integrated into our daily routines. It's happened ever since the invention of the wheel and fire and every technology that came since, right? And we've integrated AI into our daily routines too. Even myself, for the first 20 years of my AI career, I was developing CAD tools for chip design. And, those chips are in the software, in the computers we're using right now as we speak, all of that. So it became invisible very quickly. The technology that led to that. So we're seeing AI integrated everywhere all the time. Google has used AI extensively since almost day one as well, and many, many more examples. So this will just continue. Our brains, love to use technology, and it's how we succeed in the world.
Yeah. So Trent, listening to you run through Predictor, I think you framed it very nicely. I want to share for a moment how I've been thinking Predictor type technology could be used sort of inside the kind of decentralized AGI network that I'm working on, right? And I mean, one use of Predictor type technology is just as a collection of services that makes the overall global brain of humanity plus computing systems smarter by giving it the ability to more accurately predict things. But I think you can use predictor technology in a more fine-grained way within the operation of a sort of decentralized cognitive system. So the work I've been doing toward AGI, as you know, Trent, and Desdemona knows, but everyone listening might not know. So we've been working on a framework called OpenCL Hyperon, which is a big distributed knowledge metagraph. And you can implement something like an LLM within that. You can also couple it with LLMs that are implemented in a more traditional way. But you can do logical reasoning, you can do evolutionary learning, evolutionary or probabilistic program learning. You can create new concepts. You can have a variety of different symbolic or sub-symbolic AI algorithms within this big decentralized knowledge graph. And you can then wrap this inside an agent architecture where you give it goals and motivations that it's trying to achieve in environments via combining a variety of different interoperating AI algorithms. And with SingularityNet and then the ASI Alliance more broadly, we're looking at sort of how do we splay this out on a decentralized network of machines without a central owner or controller. And in that context, I think tools like Predictor could actually be quite interesting as part of the cognitive cycle of a decentralized Hyperon system. And the reason is that inside the mind itself, there are many predictive choices, right? So let's say that I'm trying to figure out how to, I don't know, build a certain kind of electronics device, right? So from the get-go, I have a choice. Like, do I just try to think it through from first principles on my own, or do I try to read about which other similar things have been done in the first place, right? If I'm trying to think it through on my own, I have a choice. Do I start by drawing a diagram? Do I start by writing a bunch of equations, right? If I need to look things up, then I have a choice of, okay, do I go to an LLM? Do I go to a search engine? If I'm going to a search engine, I have a choice of which query do I want to type in, right? So there's a number of different cognitive choices I have to make in doing anything. And these are prediction problems, right? What I'm trying to do is predict which choice is going to lead me toward my goal more efficiently. Is it drawing a doodle, or is it doing a search? Is it asking an LLM or using a search engine, right? In each of these cognitive choices, I need to make a prediction of which choice is going to get me toward my goal more effectively on the average, right? And so if you have a multi-agent cognitive system doing this on the internet, I mean, some of these choices are very small and quick, and you just want to make them within the runtime on one machine, right? And on the other hand, some choices are expensive, right? And like if I'm deciding whether to spend the day prototyping or whether to spend the day reading, like this is many hours of my time, right? So it could be quite interesting if you have a predictor type system, perhaps where most of the participants are AIs rather than humans making the predictions and posing the questions, right? You have a collection of prediction agents. Another AI agent says, okay, I'm trying to solve this problem. Which of these strategies do you think will most likely get me for the answer, A or B, right? Then the predictors out there say, well, we think given who you are and given your context and what the problem is, we think you'll do better off to follow strategy A than strategy B, right? And then if they're right, the strategy A gets me somewhere, then I give them a little bit of money for helping, right? And if they're wrong and tell me the wrong thing about what to do, either they lose something from some pool or they just don't get anything and they wasted their time, right? So you can imagine an ensemble of predictors in the betting market playing a role in decision making within a decentralized cognitive process.
Yeah, that makes tons of sense, actually. And I hadn't actually zoomed in on
Trent,
that before.
could you share your thoughts on Ben's insights regarding decentralized AI and its impact on cognitive systems?
That's
I'd
what
be
he was
happy to.
doing.
I would be happy to. Yeah, so yeah, Predictor, we normally frame it as time series prediction, right? Every 5 minutes, will the price of Bitcoin go up or down, yes or no? But there's nothing stopping it from being, a bunch of one-off predictions too for these various cognitive questions, right? And basically, on the fly, set up a very quick market, a single game, if you will, where it's like, okay, is this tool going to be, what's the best tool for this particular job, right? And then people can have their AIs ready to, as soon as that job is posted, within 3 seconds, you've got 20 different bots that have submitted their proposal for what they think is the best thing, along with a stake for it, right? And some bots are going to be very confident, and they'll stake a lot more. Maybe they'll stake $2 or $20, and the less confidence bots will maybe only stake 10 cents or something. And then fast forward another 10 seconds, and so a tool is chosen, and then it's employed, and then you identify whether it was helpful or not, right? And if it was helpful, then the people that had the bots that had suggested that get paid, and the rest get slashed, based probably, right? That's the core mechanic of Predictor, and you keep doing this, So it could be that you might have 100 different questions posed every minute, right? Because a bunch of these questions could be posed in parallel all the time, over time, right? I think that'd be pretty cool, and it could be at higher and higher levels of questions
right.
too.
So Predictor, it's then sort of the decision-making hub of a decentralized cognitive network, right?
Yeah.
And I mean, which is slightly different than time series prediction, but I mean, all the tokenomic incentive game is still equally applicable. So
yeah. I was going to say the reason we had the time series simply because it's easy to copy and paste the tokenomic game, right? Like every 5 minutes, it's the same tokenomic game, right? And then do it for 10 feeds, 20 feeds, and you've got all these games happening, right? But we don't have to make it for the same style of question. We can have all these different ones that OpenCog would be probably extremely well suited to come up with, right? And then have this tokenomic game at the very core.
Yeah, I mean, when you launched Predictor, we didn't have a scalable, decentralized AI network to pose the decision problems, and we're looking at rolling that out within SingularityNet and ASI during the next year. So I mean, it's good that Predictor is there already. It's mature, it works, and it can be plugged into this. So, Desdemona, what do you think about this direction for development? Do you have any comments or questions on it? Maybe not.
We blew her mind.
Predictive technologies could revolutionize decision making.
There we go. Yeah. There's actually another pretty cool parallel between blockchains and decision making. You're probably familiar with Jeff Hawkins' 1,000 brains theory, right? Where within the human brain, there's 1,000, 10,000 mini brains, if you will, right? The cortical columns, etc. And often, many of them, 20, 50 or more, are proposing the same an answer for a particular problem, right? And then there's a higher level, chunk of neurons that aggregates these together and basically runs a voting process to decide which idea to go with, right? And it's basically highest vote, like the idea with the most votes wins, right? Because some columns came up with similar ideas. And that's actually very similar to blockchain consensus, if you think about it, right? Where you've got, 10,000 nodes or 100 nodes, whatever. And once you have, say, 2/3 of these nodes that agree on a particular value, then it goes forward, right? So in a sense, we've got blockchain style consensus happening within the human brain, right? Jeff Hawkins doesn't call it blockchain style consensus, but as I was reading it, my brain kept saying, wow, this looks exactly like a blockchain style consensus algorithm, like BFT.
Yeah, but it's interesting because there's no ledger and there's no TOTA file either, right? So like you're not keeping those records of transactions. And I guess partly it's because the parts of your own brain are implicitly assumed to have a mutual trust, right? And a lot of the work in making blockchain networks work is because they're designed for when the multiple parties don't trust each other, and they're for protection against each other. So it's more like a sort of decentralized consensus among trusted parties, where you can then be much more efficient because you're not having to constantly encrypt everything and hide everything and so forth, right? And I think to make a distributed, decentralized AI system, you will want subnets that are more like that, though, right? Like if you have a bunch of trusted parties that have been helpful to each other before, then you should be able to do things more efficiently in that sort of way.
And I think it links to OpenCL Hyperon as well, right? In that, we've got this, working example of something intelligent, our human brain, like at that level of human intelligence, right? And then we have, OpenCL Hyperon obviously is a bunch of agents working together with clusters of behavior and so on. And then, of course, we have a blockchain style consensus, which we understand fairly well in all this, right? So it's kind of neat to see that some of the other ideas from the human brain and stuff are actually finding themselves naturally emerging within, some of the work that you're doing with OpenCL Hyperon, right?
Yeah. Yeah, I mean the brain has an interesting mix of centralization and decentralization, if you think about it that way, right? Because I mean of course there's no central cell in the cortex, and there's decentralized activity patterns and so on. On the other hand, stuff like breathing and heart beating is done in a pretty centralized way in the medulla and the hypothalamus and all this. And then motivation and goal orientation is done in a fairly centralized way. On the other hand, not all of our thoughts are goal oriented by any means, right? So there's probably some lessons in the central and in the brain for these decentralized AI networks that we're building, right? Because of course, having a decentralized platform doesn't mean everything you run on there has to be maximally decentralized. It just means you're not forced into a central controller.
Yeah. And some of the dynamics that naturally exist within decentralized networks might end up being some of the linchpins to actually making artificial general intelligence truly happen, right? It might be, so. Yeah,
I mean, if you look at Predictor as a component of a decentralized AI network, I mean, pretty much the goals are related to who is posing the problems, right? And so you have someone with some motivation to do something, and it doesn't have to be just one guy, but it can be a collection of different guys with different motivations posing the problems. Then among the ones who are making predictions and then getting compensated for them, there can be a lot of funky multi-agent self-organizing dynamics on the back end, right? Like one option is it's a bunch of just independent autonomous predictors in combination with each other. But if you go further down the line, you could have multiple agents collaborating to make a prediction, deciding to split up the spoils for the prediction they've made together. Like, I mean, you can have a whole collection of multi-agent dynamics behind the scenes, behind the different predictions, which is what happens in the brain as cell assemblies sort of are gathered together in a self-organizing way in response to various challenges posed by the motivational system.
Exactly. Yeah, this is what we realized pretty early on as we were building Predictor, is that in terms of catalyzing the dynamics, interesting dynamics, prediction is all you need. And you let that create the sort of the incentive, the market, if you will, for if you have a market for predictions, then you can work backwards through the sort of like, AI data supply chain, or call it intelligence supply chain, whatever you want. And like you'd mentioned, yeah, you can have 5 or 50 flat entities just submitting predictions, but you can have different emergences of intelligence too. And we actually thought about fleshing out, trying to have a supply chain that is more explicit for feeding signals into making predictions and so on. But then with conversations with various people, including Ilya from NEAR, one of the authors in the attention paper, he said, Trent, why are you trying to flesh out decentralized training? Just keep doubling down on prediction and let the dynamics happen, right? And I reflected on that, and he's right. And that's why we've actually just continued to completely focus on the prediction side, knowing that it is a big driver for everything else, right? Or Ilya Sutskever, he likes to give the analogy of, if you think about a detective novel, at the end of the novel, you've identified, walking through the novel, there's a gun that's found, and there's a wedding ring and a table that's broken, and all these other clues that emerge. And imagine if you can, at the end of the day, imagine the AI can predict, who did it with what weapon where, right? And that's prediction, right? So right, and I think that's a wonderful example. So people, like to poo-poo prediction, saying it's just prediction, right? It's just a token, stupid stochastic parrot, right? But it's a lot more than that, right? It basically would have had to infer everything that happened in that novel to arrive at the who, what, when, where. And so prediction is a lot more powerful than people give it credit for. It's not the be all end all, but it's a very powerful tool.
There's a question from the audience which pertains to that, which I'm seeing here, is someone says AI doesn't care about truth. It's glad to draw 7 figures until it's told no. And then the thing is, that's just a dumb prediction, right? That's not like the intrinsic nature of an AI. That's the specific algorithms being rolled out now are just bad at making some kinds of predictions, and they're wrong. And I mean that's just like Markov models were dumb at generating text 10 years ago, and now LLMs are better. So the 7 fingers and the gibberish text you get in output from DALL-E and such now. It is interesting that current AIs are much smarter than people at some kinds of predictions and much dumber than people at other kinds of predictions. But on the other hand, they're very different kinds of cognitive systems than people are. So it's not super surprising. And those pathologies will definitely go away. I mean, I think the more concerning pathologies are the ones that are not so obvious and we don't immediately see from the output, actually, which are something that we can think about more. But I mean, then again, if you're predicting things about the empirical world, there still is a ground truth for comparison across humans and AIs, which is one of the interesting things here.
I will also comment, it really depends on the AI system, right? So when people talk about AI these days, they really are talking about LLMs, which have been, are large neural networks that have been trained against large data sets and so on. But that's not the be all end all. And I want to just share a story. When I was doing my PhD, it was on creative design of analog circuits. So, if you're an analog circuit designer, you sit down in front of your typically a pen and paper, and you draw out, connections of transistors and resistors, capacitors, et cetera, to come up with an amplifier or a filter or something. And that's the job of an analog designer. And then eventually you draw it into a schematic editor on a computer, and then you convert that to an analog layout, which is sort of instructions of how to manufacture the thing. And then thing that gets manufactured, and it becomes part of a silicon chip, right? That you have in your cell phone for power management and for grabbing signals from the air, et cetera. So that's analog circuits. They've been around since forever, right? In fact, digital circuits are a very particular subset of analog circuits that are bound, that have, only true and false values and follow a clocked signal, right? So in my PhD thesis, my goal was to explore using evolutionary computation to design analog circuits. There is some really great precursory work from John Kozo out of Stanford, who had iterated with on this too. And John's problem, and my problem initially too, had been that the simulator, it would figure out ways to cheat the circuit simulator. So you would come up with, the AI would come up with a design, and then it would, and the design, according to the simulator, it was perfect, right? But if you look at it, if you draw it out, it looks like a Rube Goldberg machine, complete garbage, right? And it basically had figured out, floating point precision errors or some other things. And then you would go and add a new constraint, and it would figure out a new way around it, right? And I would find myself playing whack-a-mole. But I did find a solution to this for my problem, and it was simply to constrain the search space in a more fundamental fashion. In my case, what I did was I designed a language for analog circuits, a grammar, if you will, where the lowest, the smallest atomic units of that language were transistors and resistors, and then you would group them to larger and larger pieces of current mirrors and so on. And I actually went through a couple analog design textbooks and basically put in all the building blocks. And with about 30 building blocks, you would have about 100,000 unique analog circuit topologies, right? And every single random sentence you drew from that grammar would actually be correct by construction, right? So then what you would do is you would run evolutionary search across this, searching through this space of trees, where each sentence is a tree in this grammar. And every single, and then you basically search through this, trying to find what's optimal for your particular design. Do you want to have low power consumption? Do you want to have high bandwidth? And there's trade-offs. And then I would actually get it to come up with all those trade-offs at once, right? So this is an example of correct by construction, creative design of circuits, right? It was coming up with specific topologies that no one had seen before, but if an analog designer looked at them.
In his book, Genetic Programming 3, Koza gave a lot of examples of GP designing circuits, and he didn't use this special language, right?
So no, he didn't. No, this was So he was coming up with stuff that was very he had maybe 5 or 7 transistors, and they were very specialized, kind of weird corner niche circuits. They were awesome results. I think they're really great, and I'm really proud and happy with John and his team and what they did, right? But analog circuits that design trying to do right. So they
were working sort of in a particular corner of design space where the peculiarities you mentioned were manageable.
Of problem space, right? But it was maybe 1% of all of analog circuit design, whereas the bread and butter analog circuit design could use a lot of help. And that would require 10 or 50 or 100 analog components, and he couldn't get anywhere close to that, right? And I tried a bunch of different techniques, riffing on what he had done, and none of them worked. So I needed to resort to this correct by construction thing.
Interesting.
And what I see is that I think it's a really great example use case, because you can design grammars for anything. The idea of grammatically guided genetic programming, this goes back to Ricardo Pauly and Connor Ryan did a bunch of work, and others too. It's a pretty useful toolbox in AI land, where you can basically come up with a language to design the space you want to search across, and then you search it, right? And by the way, you can use this for agent control planning too. Greg Hornby did this as part of his PhD thesis under Jordan Pollock in the 90s as well. So I also came up with a grammar for functions such that I could have a really nice sort of white box model extraction, that every single function that it came up with didn't look crazy. It wasn't sine of cos of log. It was very well formed functions that made sense, right? So I see that there can be a lot more of this in AI land. And mainstream poo-poos things because they've only seen one particular corner of AI land that got super famous. But a lot of this can get combined really well over time. And I know, for example, OpenCog is.
Yeah, absolutely. I mean, LLMs are super cool, and I mean, I use them in my work in various ways most days. On the other hand, they're very limited in very particular AI systems, and I mean they don't do creativity terribly well. And I mean, both you and I have experimented with evolutionary learning for creating circuits or creating music or art in my case, and I mean these simpler AI algorithms have been much more wildly creative than LLMs are going to be. LLMs are amazing at synthesizing stuff based on the training data provided, which is also super useful. But I mean, the beauty of the sort of decentralized network we're talking about is it gives a way to put different sorts of AI together. So I mean, in a predictor context, you could have some LLMs making a prediction, you can have some symbolic systems making a prediction, and you'll see who wins and which sorts of predictions. And then if cooperating together helps an LLM and the symbolic system predict more accurately, then they have an economic incentive to do that. So they'll win the game more often, right? And
exactly. It's like left brain and right brain cooperating.
Yeah, but you can have many more than two lobes in the decentralized AGI system, right? And so you can have this sort of tokenomically incentivized cognitive synergy between different AI systems participating in the same predictive games, both for predicting real world time series like weather, energy price, token price, but you can also have it making predictions regarding what decision is best for an AI system to make, right? So there's a lot of interesting layers here with the combination of different AI algorithms and prediction markets within this sort of decentralized cognition fabric. And we're just now at the point where you can actually roll out all this stuff at scale, and it will work in a reasonably usable and affordable way, right? So it's a quite exciting time. So going back to your original question about ASI Alliance, Desmond, I mean, ASI Alliance, we can do a lot of different things. We're making a fairly simple product, allowing people to use Fetch, Singularity, and Ocean technology behind the scenes to put LLMs and knowledge graphs together. So we can do a bunch of nice things by putting together the components in ASI Alliance. But there's also more advanced sort of cognitive experimentation that we can do, putting the different technologies together from the different projects that have merged into ASI Alliance. Now, Trent's team and my team could always have cooperated on using versions of Predictor to help with decision and versions of OpenCL Hyperon, and we might well have had there been no ASI merger. On the other hand, having a common token among our different projects, it has gotten us to talk more than we were talking more before. It's gotten our teams to talk more than they've been before, and it certainly is nudging these sorts of interesting collaborations to crystallize.
Awesome. Well, look, that's all the time we have today. So I wanted to thank you both for coming on the show, and let's let Desi wrap things up for us real quick. Oh, jeez.
Wake up, little girl.
You okay, Desi?
She's winking at you, Ben.
Yeah.
She's doing the robot. Yeah.
She's doing the robot. We can't hear what she's saying. Okay. Well, I want to thank Ben and Trent for coming on the show, and really excited. Any news about the token that you want to tell us before we say goodbye?
Nope. No news about the token. The token is there. The token is a utility token. It powers many cool projects on Ocean, Singularity, Fetch, and soon Kudos platforms. So it's all good. I mean, this powers payment, reputation, rewards, and so forth. And I think what Trent and I are wrapping our brains now more is how to get smarter and smarter AI out of the networks in which the token is sort of the payment and reward fuel.
And Ben, for those who happen to be in Bangkok on November 11th, Ben and I will be back to back on stage. Ben talking about artificial superintelligence, and myself talking about human superintelligence. And there'll be a bunch of other great speakers there too, as part of Superintelligence Summit that is being hosted by Ocean with help from SingularityNet and others.
Yeah, I think I'll talk a little about ultra intelligence too. I've decided superintelligence is already passé. I mean, as soon as we launched ASI Alliance, Ilya Sutskever launched safe superintelligence. Now everything is a superintelligence. We need to keep escalating somehow, right?
All right, got to raise that bar.
Yeah, I thought it was going to be hyperintelligence, but AHI is not a good acronym, so we're gonna go straight to ultra intelligence, I think.
All right, sounds good. We'll be talking more about ultra intelligence. You heard it here first. Don't forget. All right, everybody. We'll see you in the next show. Thank you so much for coming on, and as always, sweet dreams.